Hi everybody, and welcome to 3D survey tutorials. In this video, I'll be showing you a basic workflow from images to orthophoto. First, I would like to show you the basic results we get by flying the drone over the area. In this case, we were using Phantom RTK, which made 140 images, overlapping each other 70%. In the end, we have a GCP file containing 6 ground control points measured with a GPS instrument. Okay, now the first thing we need to do is click New Project and import all the images by clicking the first one, then holding Ctrl-Shift and selecting the last image. We confirm our decision by clicking Open. Now we can see the Telemetry importer window has automatically popped up. The first thing we do is select EXIF data, as most DJI drones, including our one, write information this way. Then we select our project coordinate system. Our project was done in Slovenia, so we will choose Slovenia 1996. And the third thing is we select vertical coordinate system. In our case, we will use EGM 96. To confirm our decision, we click Import. Now, we can see some technical information about the images, including the accuracy, which we can see is very good. Next thing we'll do is close the window and click Telemetry. After doing so, we'll be able to see the pyramids, showing us how the drone was flying and where the camera was pointed. If we click Toggle Text button, we'll hide the text and be able to see the pyramids better. On the right, we can see how many images were registered. In our case, we can see that number is 140, which means that we were able to register all of them. In the bottom right corner, we can see the steps we need to do. The first one is bundle adjustment, so let's just click on it. Now, we see 3 modes and we will choose global, as it is the fastest and the most stable. To confirm it, we click OK. We'll have to wait about 10 to 15 minutes to get our results, so see you shortly. Hi everybody and welcome back. Our bundle adjustment step is finished, so under the pyramids, we can see our sparse point cloud, which connects our images. The next thing to do is orientation. We'll click Orientate and choose orientation with GCP data. Next, we need to import our GCP data, so we click on Browse and select our GCP file. Now, we can see our control points and their coordinates. There's also a lot of options to change coordinates. Because we used an RTK drone and we have the right coordinate systems, we can also choose known projection and click Import. Once again, we can see the coordinates of our ground control points. We can also see the diameter of the black dot on our 3Dsurvey target. After doing that, we click on Next and go to our orientation wizard. The first thing we see is our first image. On the top right corner, we can see a mini-map containing ground control points. The next thing we need to do is click Next Image and try to find our first ground control point. After we spot it, we zoom in by using scroll wheel and we will see an actual target and a green circle representing the estimated position of the target. We will also see a number, which shows us which ground control point this is. If the circle is not already on the target, we must click the number of the target on the mini-map with the left mouse click and then also click the middle of the target with the left mouse click. By doing this, we have improved our position of the first target. Now let's click Next Image button a couple of times and try to find our next target. If you zoom in right there, you can see another target without any green circle next to it. That is because guys in the field laid it out, but forgot to measure it. If this happens, the thing to do is just to ignore the target. Now let's click Next Image button a couple more times and try to find our next target. Okay, now we've found our second target, so let's just repeat our process. We can see that the number of the target is 8001, so let's click it on the minimap with the left mouse button and then also click the middle of the target with the left mouse button. This is how we improve the position of the targets. Let's click Next Image button a couple more times and find ourselves another target. Okay, so there we can see target number 8003. So we'll just repeat our process. In the bottom right corner, we can see the accuracy of the targets we have already found. So this is basically what we do here. We find targets and try to improve their position. Here we can see the target number 8004, and we also see the green circle is already positioned on it. That means that it is already well positioned and we do not need to move it. Also, as a tip, you can move faster through the images by clicking the specific image on the list on the left. Okay, so now it looks like our job here is done. Also, because we were using 3Dsurvey targets, we should make sure the Tag GCP target box is checked. Now what we do is click Next and wait for our GCPs to be detected. Now we are sent to Detection Overview, where we center the targets. We can see that the targets of ground control point number 8006 are already perfectly centered, but not so well for the 8005 one. If the images are red, it means that they are deactivated and won't be used in further processing. To activate them, we double left mouse click them and improve their position by clicking the left mouse button and dragging them. If the target is not seen, we can zoom out a bit by using our slider on the bottom. The more targets we center, the higher accuracy we get, so I suggest you center as much as you can. But since this is a tutorial, I think we have done a good enough job. Also, make sure that the targets which are not seen in the picture are red, which means deactivated. After you're finished, you click Next and wait for the results to show up. We can see that we have less than 1 cm 3D accuracy, which is very good. So now, let's click on Finish. Immediately, we see the results and our 6 ground control points. If we expand the right window, we can see the values once again. That is it for orientation step. So now, we move on to reconstruction. To do it, we click on Reconstruction. The first thing to do is select our reconstruction level. I suggest you choose High, which is already set by default. The second thing is we must make sure the box is checked if we have NVIDIA graphic card, which we kindly advise, as the process will be so much faster and you won't need to use your CPU. So now we click on OK and the dense reconstruction process will be started. This process will take about an hour and a half on my computer with an average graphic card. The better graphic card you have, the faster the process will be. Welcome back. Here we can see the results of our dense reconstruction step, or as it is called, a point cloud. We can rotate the model by holding the left mouse click and dragging the mouse. We can also zoom in for details by double left mouse clicking on the area we want to zoom into. We can also use the scroll wheel to zoom in. We can see that our point cloud is extremely detailed, with every single point having its own coordinates, which is basically impossible to accomplish by doing this the traditional way. The next thing we need to do is classify our point cloud, so let's click on Classification. Here we can adjust some parameters, but for 90% of the projects these are totally fine. Now let's click on Next. As we see, it asks us to click on some biggest terrain regions. We do it and click Next. The software will then show you what it thinks is terrain by coloring it red. If you're happy with the marked area, click Finish. If you're not happy, just click Recalculate a couple more times. Now, let's click Clear and deselect our area. In the list of point clouds on the right, you will see that your point cloud was separated into 3 different classes. The first one is called Never Classified. It is a class where points were before classification. The next one is called Unassigned, and it contains all the areas you removed by classification. The last class is called Ground, and it contains only the ground points. Now the next thing we need to do is create our DSM from ground points. So we deselect our unassigned class, click Mesh, and click Calculate New Regular Grid Mesh. Choose grid cell size 1 meter, hole filling mode as optimized, and smoothing size 1 cell. When the DSM is created, we click on the orthophoto and choose Calculate New Top Down. We choose the traditional orthophoto with the grid size of our DSM and click Calculate. At last, we can see our traditional orthophoto. This is all for this tutorial. Thank you and see you next time.